Hi, my name is Travis McVeigh. I'm an anesthesiologist from Dallas, Texas. I host a podcast called Thank You Notes at Ars Longa Media. Showing gratitude to people just makes me feel good, and I want to share the practice of thank you notes with everybody who listens. I write thank you notes to people and then bring them on the show to read it to them. Past guests have included my high school teachers, my friends, other physicians, and a couple of internet celebrities. I will also be doing episodes that explore the science behind gratitude practices to demonstrate to everybody the actual tangible benefits of practicing gratitude. Listen everywhere you get podcasts and check out the extras on my social media accounts. Thank you for listening.
This episode and the Study Smarter series is made possible by Osmosis. You can get a free trial of Osmosis Prime by going to osmosis.org. To be honest, we've had a little trouble keeping up with the mini episode plan to put out 1 to 2 per week. So what we have decided to do is to release this mini episode and then in about 2 weeks to just release the rest of microbiology every other day. So stay tuned for that. We will probably do the same thing with the pharmacology portion of our mini episodes for the Study Smarter series. And then stay tuned for full-length episodes with Doc Osere, the Brosencephalon, Dustin Williams from Online MedEd, and Eli Fryman from Med School Tutors, as well as a few other notable guests. Thank you, as always, for listening. Don't forget, you can stay up to date with what ITB is doing by going to InsideTheBoards.com and subscribing to our email list. Happy studying.
Hello, I'm your host, Elizabeth Eamon, and I'm back today with another one of our mini episodes for the microbiology portion of the Study Smarter series. Our question today is, a 23-year-old woman comes to urgent care because of 2 days of mild fever and painful urination. The patient states that she's been urinating more frequently and does not feel as though she's fully emptied her bladder. She denies seeing blood in her urine, abnormal discharge, fatigue, or increased thirst. She's not currently sexually active and states that she has a regular menstrual period. Physical examination is unremarkable. Urine culture detects the presence of a gram-negative rod bacteria. Which of the following virulence factors contributes to the pathophysiology of the most likely microorganism causing this patient's symptoms? And the choices are A. Exotoxin A, B. IgA protease, C. P. pilus, D. P1 antigen, or E. protein A. And the correct answer is C. P. pilus. The patient in this question most likely has a UTI. We know this by the painful urination, more frequent urination, and the most common cause of UTIs is E. coli. E. coli is a gram-negative rod. It's part of the normal gut flora. Most E. coli strains are innocuous, however, several strains are pathogenic and can colonize the urinary tract. There's an enterotoxigenic form of E. coli, that's the E-tech, enteropathogenic, which is E-pec, enteroinvasive, which is E-IEC, and enterohemorrhagic, which is E-hec. E. coli has several different virulence factors. Pili is just one of them. It also has a K-capsule, lipopolysaccharides in the membrane. Uropathogenic strains that cause urinary tract infections express a specific P. pilus which binds to Gall-1,4 on uroepithelial cells and allows the bacteria to colonize the bladder. Infection typically occurs when the urethra is exposed to fecal bacteria. The bacteria eventually reach the bladder and, depending on severity, may reach the kidneys. Because women have a shorter urethra, they are more susceptible to infection. Women with a urinary tract infection typically present with painful urination, dysuria, and mild fever. Medical history and laboratory studies can confirm the diagnosis. Treatment is with antibiotics. To review quickly the other wrong answer choices you might have been tempted by, we have exotoxin A. You may remember exotoxin A is a virulence factor released by Pseudomonas aeruginosa. It functions by inactivating elongation factor 2 and results in host cell death. Remember, elongation factor 2 is part of DNA replication. Something that you should know about Pseudomonas, other than that it creates exotoxin A, is that it is known to have a blue-green pigment. It has a fruity odor when it's grown in the lab, and also it is an encapsulated organism. Like many of our other bacteria, it uses that as one of its virulence factors, that capsule. The other organisms we know of that have capsules include Streptococcus pneumoniae, Haemophilus influenza, and Neisseria meningitidis. Remember, people without spleens are especially susceptible to infections with encapsulated organisms. Choice B, IgA protease. That is an enzyme secreted by several different bacteria, Strep pneumoniae, H. influenzae type B, and Neisseria. The IgA protease is the virulence factor that's used in order for these bacteria to colonize the respiratory tract and create pneumonia. The P. pillis we already discussed, that was choice C, and the correct answer associated with the E. coli and its virulence factors. Choice D, the P1 antigen. The P1 antigen is the primary virulence factor for Mycoplasma. Mycoplasma genitalium can infect the urethra, so that can be a little bit tricky, but it doesn't really infect the bladder. For this reason, we don't classify it usually as a urinary tract infection. It could have had these similar symptoms, certainly. However, the vignette describes the bacteria as a gram-negative rod bacteria. Mycoplasma is actually one of the bacteria that doesn't have a cell wall. For that reason, it doesn't really gram stain. So we would never hear a description of it being a gram-negative, gram-positive bacteria. The other ones that don't gram stain well include Treponema, Legionella, Rickettsia, Chlamydia, Bartonella. These all don't gram stain well. We do know Mycoplasma is a very common cause of atypical pneumonia. Choice E, protein A, is a virulence factor expressed by Staph aureus. It binds the Fc region of IgG and prevents opsonization and phagocytosis. And we have a whole episode that we've already talked a lot about Staph aureus. Recommend checking that one out. The things you should know about E. coli are that there are different strains that act in different ways. So let's run through them really quick. E. hec, enterohemorrhagic E. coli, has a Shiga-like toxin that is an rRNA, reverse RNA, and it enhances cytokine release, causing hemolytic uremic syndrome. Unlike Shigella, which can also cause this, E. hec doesn't invade host cells. So that would be the difference pathogenically of how those two work. For enterotoxigenic E. coli, it produces a heat labile and a heat stable toxin. The heat labile toxin overactivates adenylate cyclase, increasing CAMP, and increases chloride secretion into the gut. Where chloride goes, water will follow. Water goes into the gut, and there's lots of diarrhea. Making this worse is the heat stable toxin, also released by ETEC. That overactivates guanylate cyclase, increases cGMP, and decreases resorption of sodium chloride, salt, from the gut, and therefore more water stays in the gut, makes the diarrhea even worse. So remember, watery diarrhea is labile in the air, adenylate cyclase, and stable on the ground. Stable goes with G for ground, goes with guanylate cyclase. E. coli is a gram-negative rod. It has multiple different virulence factors, including fimbriae, that can lead to cystitis, even pyelonephritis with the P. pili, has a K capsule, which leads to pneumonia, can cause neonatal meningitis, has an LPS endotoxin, which leads to septic shock. And the different presentations of the different strains, EIEC has microbes that invade intestinal mucosa and cause necrosis and inflammation. This is invasive and leads to dysentery. Looks like Shigella. ETEC, enterotoxigenic E. coli, produces the heat labile and heat stable enterotoxins. Doesn't have any inflammation and no invasion of cells. Causes the watery traveler's diarrhea. EPEC doesn't produce a toxin at all. It adheres to apical surfaces, flattens the villi, and prevents absorption. This leads to diarrhea, usually in kids. You can remember P for peds, P for EPEC, and E. hec is the one associated with that O157H7, the most common serotype in the US, and leads to dysentery-like diarrhea. The toxin alone causes necrosis and inflammation, and it's hemorrhagic, transmitted through hamburgers, and can lead to hemolytic uremic syndrome like Shigella does. So that's E. coli.